Hello everyone. I welcome you to this class of econometric methods. Myself, Dr. Muhammad Imdadul Haq, an associate professor in the Department of Economics at Aligarh Muslim University. Today's lecture is in continuation with the earlier lecture on simultaneous equation models. There is a phenomenon that regarding identification. So, the issue is that a model has to be identified, only then you can estimate its parameter. This is one of the assumptions of classical linear regression model also. But we didn't discuss it when we were discussing the single equation models, that is yt is equal to alpha plus beta xt plus ut. The thing is, a model is said to be identified if it has a unique statistical form. So, unique statistical form means that it enables unique estimates of the parameters from the sample. The issue is, if the model is not identified, then estimates of the parameters cannot estimated. So, this unique statistical form means that there is no other equation in the system or formed by the algebraic manipulation of other equations of the model which contains same variables as the function in the question. This will be clear in your upcoming discussion. So, identification is finding unique solution, finding of unique solution for the structural parameters. And one thing, it's not a problem of model estimation. It is a problem of model formulation rather. So, let's take now, we come to an example to understand it. From the pictorial representation, we can know that this is the demand function. So, this is the demand function. As we see, there is an inverse relationship between price and quantity, and the second one is a supply function. We see a positive relationship between price and quantity. So, you can say that, okay, here this is demand and this is supply. Agreed. Let us move to the next. Now, here we are having, from this it is not very clear, but see, equilibrium of demand and supply. And to obtain the estimates, we use data. But and the data is such that quantity demanded is equal to quantity supplied. Market price is the equilibrium price. So, we cannot say that whether it is the demand price or the supply price. We are observing from the market that this is the price. Now, whether this is the price for the demand function or the supply function, it is. Two people can contradict. If they see this picture, they will say, no, this is the demand function. Somebody will say this is the supply function. So, okay, that is theoretically whatever you say, but when you go for empirical estimation, you have to be very sure of it. So, this is one diagram that the demand, which you say from the pictorial representation, we can say the demand and the supply, but actually this is the case inside. These prices, they are an intersection of demand and supply. So, we will not be able to identify the demand and supply function even if there is a very high correlation, as the data points that have been generated are generated by the intersection of demand and the demand curve and the supply curve, the demand curve and the supply curve, the demand curve and the supply curve. That is, any model in which equation contains the same explanatory variable. In demand function, demand is a function of price. Supply function, supply is a function of price. You can take d is equal to alpha minus beta p1, or s you can take d is equal to alpha plus p. But the thing is, price is present in both the two equations of the same model. We refer to this as the mongrel function. That is a function which is a mixture of both demand and supply forces and whose coefficients are a mixture of coefficients of both the functions. So, identification, it is the criteria to verify which coefficient belong to which relationship. See, demand and supply are determined by many factors other than price. There are many factors. Now, changes in these factors could cause a shift in the curve. So, we must have information on the shifts of demand and supply curve in order to be able to identify the coefficients of the relationship. Meaning thereby, now what we are seeing in this curve, the demand curve is shifting, but it is shifting only once, but the supply curve is shifting multiple times from here to here to here to here, and the demand curve there is shifting only one side. So we can say that the demand is relatively stable. What is our purpose? We need to know, we need to identify the shifts. In this diagram, demand is relatively stable. As case, we can say that the factors like income, taste and other they don't change very quickly. Now, what is my taste and preferences? What is my income? It will be almost the same in at least few consecutive periods. Why say supply is shifting? Due to, if you take an example of agricultural products, the supply anytime today some commodity prices has increased drastically, tomorrow some other commodity price has increased drastically because of weather. If there is heavy months, if there is more of a rainfall, less of a rainfall, all these things they tend to fluctuate the quantity of agricultural commodities availability. Now, so this could be one case. Let's go to the other. And another case could be that the demand supply curve is relatively stable, but the demand is changing, say because of war, or suddenly there is a change in suddenly there is a fashion, or there is a medical emergency and there is a need of something. So because of changes in income, taste and abnormal situations like war, it may be that the supply is already the same supply is there, or there is a small change in the supply, but there is a huge change in the demand, although the supply change is very small. So we need to, what is being emphasized over here is we need to know the shifts in the demand and the supply, or the functions which are to be identified. Now this is a case wherein both the demand is also, the supply is also shifting, the demand is also shifting, the supply is also shifting. So both the things are shifting over here, the demand and supply. So this is one of the case. So if we know the factors which are causing the shifts, we will be able to identify the functions. Now, interestingly, there is an identification paradox. See, there are certain conditions. The function should be relatively consistent throughout the sample, throughout the period for which we are calculating. And the next thing is, in order to identify the demand function, there must be fluctuations in factors not encompassed by, but are present in the supply function. I repeat it for the supply function. In order to identify the supply function, there may be alterations in certain variables not included in the supply function, but it is included in the demand function. So to identify the demand functions, we need factors which are not present in the demand but present in the supply, whereas to identify the supply function, we need factors which are not impacting the supply but is impacting the demand. That is why we call it as a paradox. That is, the identification of a function relies on variables that are absent from it but are operative in the other functions of the same system of equation. So that's why we call it as an identification paradox. Now let's take an example. Now, the demand function is not having, we are writing the demand function B naught plus B1 P plus U, and we need to take care that this demand equation does not have a unique statistical form, since its parameters cannot be, hence its parameter cannot be statistically identified, because the same price is also present over here in the second equation of supply in the system of model, in the system of equations of the model. So, regressing demand on supply with sample data, we cannot be sure whether the estimates. Now we have done the regression, we don't know whether this is this P is of demand function, or it should be minus over here basically, but just we ignore it at the moment, and we don't know whether it is the demand function or the supply function. So what we do, we let it be, because we have done, we let it be plus at the moment, just ignore, because this is just an example. So what we do, we are going to show you the process. What we do, that we have this demand equation and the supply equation. We do some algebraic manipulation, that is, we multiply this by K and the second equation by C. So we have KD plus KB naught plus KB1P and then Ku, and the second equation is multiplied by C, so it is CD plus CA naught plus CA1P plus CV. And this is just, we have multiplied the first equation by K and the second equation by C. Third equation is basically an identity that doesn't create any issues, so we don't do anything with that. Now these two equations we have done in our previous slide, and what we do, we simply add both of them. When we add both of them and we take common, so D is common, it is K plus C multiplied by D, then we have KD plus, we basically, it is KD plus KC, which can be also written in this format, is equal to KB naught plus CA naught plus KB1 plus CA1, and then we take P common, because P is common over at both the places, and the last term is Ku plus CV. So now we have this equation, we have a repetition. Now this, we can write it in terms of this by D, and then K by C, it will go to the denominator of the right hand side. So we can say KB naught plus CA naught divided by K plus C. The next term, KB1 plus CA1 divided by K by C multiplied by P. Then the next term, Ku plus CV divided by K plus C. Now we just assume that this term is A, this term is A1, and this term is U asterisk. So we can write the final equation as D is equal to A naught, capital A naught plus capital A1P plus U asterisk. This is what we called as a bogus equation. Because by algebraic manipulation of the demand curve and the supply and the demand function and the supply function, we obtain a bogus equation. What is a bogus equation? An equation which is neither the supply nor the demand function, but just a mixture of both the two. This equation is a mixture of both the supply function and the demand function. Next, so the process of identification requires that each one of its equation, if there are all the equations, ignoring the identity equation, if there are three equations like you have in ISLM model, we will see at some later time. So all the three equations should be identified. If there are two equations, like here we have a demand curve and a supply curve, both the two equations need to be identified. And identification of the parameter of an equation is established if you can prove, what is the proof? That it has a unique statistical form. So there are two rules of identification: order condition, rank condition. These are the two rules which are to be followed. Let us see what could be the possible cases. Equations may be under-identified. So if a system, if the statistical form is not unique, then a system is under-identified. A system is under-identified when one or more equations or all the equations or even at least one of the equation is under-identified. The moment it is, the entire system of equation, it becomes under-identified. The second case is the equation is identified. Here there are two sub cases. It can be the system of equation or the equation exactly identified, or it can be the equation is or the system of equation is over identified. Both the cases it could be. It could be exactly identified, or it could be over identified. Why we need to do all this? The reason, for a system of simultaneous equations, we cannot do OLS estimation. We cannot apply our old friend OLS over here. The reason that we have seen that the covariance, they are not zero, the estimator is biased, not an inconsistent. So we need to have different other methods, but it's not that we cannot estimate the parameters of a simultaneous equation. We can estimate. There are many methods to estimate. So what are the cases? If an equation is identified, there were two cases. If it is, say, exactly identified, we use ILS. If it is over identified, we can use another method, 2SLS. And if the model is not identified, under identified, we cannot estimate the parameters in that case. So we come back to the rules of the order condition and the rank condition. See, order condition is that the total number of variables, both endogenous and exogenous, in simultaneous equations, we do not use the nomenclature of independent and dependent variable. Rather, we use the terms endogenous in place of dependent variable and exogenous in place of independent variable. So the total number of variables, both endogenous and exogenous, excluded from it must be equal to or greater than the number of endogenous variables in the model minus 1. We will do a practical example. It will be very clear. Just hold on. So it is necessary, but not the sufficient condition. It is a necessary condition, this order condition. It may be a case that a system is satisfying the order condition, but if it doesn't satisfy the other condition, that is the rank condition, the system of equation will not be identified. And rank condition, in a system of, say, G equations, any particular equation is identified if and only if it is possible to construct at least one non-zero determinant of order G minus 1 from the coefficient of the variable excluded from that particular equation, but contained in the other equations of the model. We are basically, this rule is, we are incorporating the same thing, that is, with demand function, it is for its identification, we need variables which are not impacting the demand function but the supply function, and vice versa for the supply function. So now let us see. Now, so there are few terminologies which are used in the order condition. K, number of total variables in the structural model, not in the reduced form. Reduced form identification is a different process. We will see that later. Then M is the number of variables, particularly in particular equation which we are trying to identify. G is the total number of equations, and this is one of the formulas, G minus M. It should be greater than G minus 1. That is, excluded variable should be greater than or at least equal to the total number of variables minus 1. If it is equal to, then it is just identified. If it is greater, then we call it over identified. And the order condition is the total number of variables, endogenous or exogenous, excluded from it must be equal to or greater than the number of endogenous variables in the models less 1. This is the, in simple terms. Then the rank condition. Okay, in the system of G equations, any particular equation is identified if and if it is possible to construct at least one non-zero determinant of order G minus 1. G is the number of equations in the system from the coefficients of the variable excluded from the particular equation which we are trying to identify, but contained in the other remaining equations of the system of equation or of the model. So, let us come back to a practical example, a numerical example. We will be able to better grasp the situation. So, we take three equations: consumption A naught plus A1 YT plus U1, IT, the investment function B naught plus B1 YT minus 1 plus B2 RT is the rate of interest, plus UT, and YT is equal to CT plus IT plus GT. So, here we are having this system of equations. The last one is an identity equation. Identity equation we just ignore. We don't have to do anything with it. So, we go to the first step. The first step requires that we had an equation CT is equal to A naught plus A1 YT plus U1 is equal to 0. This was our very first equation, consumption equation. Now, we just take all these terms to the left hand side and equate it with 0. Next time, we take the investment functions, we take all the terms to the left hand side and simply we equate it to 0, and this also is done with the last equation. Now, let us see what we are trying to do. What is step 1? Write the parameters of all the equations of the model in a table, noting that the parameter of the variable excluded from an equation is equal to 0. Now see, for the consumption function, what is there any element of CT? Yes, there is. It is minus 1 over here. What is the element of IT? IT, there is no IT over here, so 0. What is the element of YT? Yes, there is an YT, so 1. What is the element of YT minus 1? There is no YT minus 1, so 0. What is the element of, is there R over here? No, R is not there in the consumption function. Is GT over there in the consumption function? GT? No, there is no GT, so we write 0. Now, let us move to the next one. In next one, that is the investment function. This is the investment function. In investment function, please note a correction. It is here minus 1. So, in investment function, is there any CT? No, there is no CT, so we add 0. Is there any IT? Yes, IT is there and it has a line minus 1 sign. And is there YT? There is no YT over there. Is there YT minus 1? Yes, YT minus 1 we have, and there is a coefficient beta 1 over there, so we write beta 1. Is there R? Yes, there is R. What is the coefficient? B2, we write B2. What is the coefficient for GT? There is no GT in the investment term. Then we take the last function, last equation. It is having YT. It is CT, yes, CT is there, so I write 1. IT, yes, IT is there, I take 1. YT, yes, YT is there, in minus format, I write 1. And is YT minus 1 there? No. So we take it. Is R over there? No. So is GT over there? Yes, GT is also there, so we say 1. So this is how you make a table of the coefficients. And this is what is your first step. Second step. In the second step, you are asked to strike out, cancel the row of coefficient of the equation which is being examined. Again, we refer back to the same thing. Demand equation I want to identify, and I need the variables which are not impacting demand but which are impacting other. So, now I want to identify the consumption function. I cancel the entire row of consumption function. I am left with these last two rows. Step number 3. Strike out the columns in which there is a non-zero coefficient with respect to consumption function. Non-zero is over here. So already we have cut it like this. Now non-zero is over here. Here it is 0. Here it is again -1. I cut it, and here everything is 0, 0, 0. So there is no non-zeros over here. So by deleting the relevant rows and columns, we are left with the coefficient of variables not included in that particular equation, but contained in the equation of the model, of other equations in the model. Now, step 4. Form the determinant g-1 and examine their value. From what is left? So what is left? -1, 1, B1, 0, B2, 0, 0 and 1. We make it a matrix. This comes over here, this comes over here, this comes over here, this comes over here. And we have seen that we have cancelled this, we have cancelled this, and we have cancelled this earlier. So we are left with this matrix. Now out of this we have to see that at least one, there can be many matrices we can form over here. We will at least one of those, out of the many matrices, it should have a determinant non-zero. So the matrices which are formed, let's take the very first matrix which are forming. That is, we take these things, -1, B1, 1 and 0. So if I want to make a matrix, the determinant, what I do, I multiply this with this. So I have -1 multiplied by 0, minus sign, and then we multiply this by this. So 1 by 0 and no, not this one. This is in reference to -1, 1, B1 and 0. So this is 1 and 0, and this is 1 and it is plus B. This is some other. Let us form this equation: -1 multiplied by 0 minus 1 multiplied by B1. So this is 0 minus, this comes 1 minus B1, that is minus B1. So B1 is non-zero. Although it is minus, but it is non-zero. There can be one more case, like this is 1, 1 and B1, 0. So this is the case which we actually are talking about. There is some calculation issues over here. In this, the determinant should, this is not any one of the determinant, because B1 and 0, now this is this column and this is this column. So it should be -1 into 0, and the next term it should be B1 multiplied by 1. So this is equal to minus B1, and this is not equal to, this is -1 multiplied by 0. So it is having a non-zero determinant. When it is having, or we can take this, let us take another example with B2, 0, 0, 1. We try to find the determinant. This is equal to B2 multiplied by 1 minus 0 multiplied by 0. This is B2, and B2 is not equal to 0. So if at least there are so many matrices we can form, if out of these sub matrices, if at least one of them is having a non-zero determinant value, then we can say that the rank condition is satisfied. Now, so the second condition was order condition. Order condition, k minus m should be greater than or equal to g minus 1. If it is, if k minus m is equal to g minus 1, we call it exactly identified. If k minus 1 is greater than g minus 1, we can say it is over identified. We take an example to explain you step by step. So Ct is equal to alpha a naught plus a1 y1 plus u1, it is equal to b naught plus b1 yt minus 1 plus b2 r2 plus u2 yt is equal to Ct plus it plus gt. Now here this k, what is it? Total number of variables in the model. One, suppose we are talking about this. Suppose we are talking about just the consumption function. So k is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it okay? Total number of variables in the model. Is it okay? Have I repeated any one of them? Yes, I have repeated some of them. IT I have taken over here also, IT is repeated. CT is repeated. YT is repeated. So the total number of variables is not 9, rather it is 6. G, total number of equations in the model. 1, 2, 3. M, number of variables included in the particular equation. We are talking about consumption function. Number of variables included is 2. So what we have seen, order condition, we are for the consumption function k, which just now we have seen k is equal to 6, g is equal to 3, m is equal to 2. So we have, our rule is k minus m should be greater than or equal to g minus 1. So k, how many? Ct, yt, it, yt minus 1, and then these are repeated, so gt and rt. 1, 2, 3, 4, 5, 6. G, total number of equations. G is the total number of equations in the model. No, G is M, and total number of equations in the model. How many we are estimating? 3. And there is a correction in the PPT, please note of it. So there are total number of equations in the model is 3, and number of variables included in the particular equation, Ct and Yt, there are only 2. So it is 2 minus 1, that is equal to, we can write it is 6 minus 3, and it is greater than or equal to 2 minus 1, that is equal to 3 is greater than 2. So since the greater than sign holds, so we can say this is an over identified equation. If the greater than sign holds, we can say it is a case of over identification. There is a small correction. I hope you have taken note of it. G is equal to 3, not 2 as such. Now let us go for, now since we have seen the process of identification, we now go for the identification of the investment function. What were the rules? First cut, what is left off in first cut, what is left off in what is the investment function. Then see where in investment function it is non-zero. So it is minus 1 over here, we cut it. This value is b1 is over there, we cut it. And it is value b2, we cut it. This is 0, this is 0, this is 0, so no problem. So we are left with a matrix minus 1, a1, 0, plus 1, minus 1 and 1. This is what we are left with the matrix. Once we are left with the matrix, we take one of them. We have just taken one of them. So minus 1 multiplied by minus 1, this is minus 1 multiplied by minus 1 minus a1 multiplied by 1. So this is equal to -1 minus a1, and whatever it may be, it is not equal to 0. So again our rule is that k minus m should be greater than or equal to g minus 1. Now we have one of them rule was satisfied over there just now before, and now one of the determinant is not equal to 0. So we can say that your investment function, no, sorry, we need to identify, we just skipped a step. We have satisfied this condition that one non-zero determinant is there. Now the other condition was k minus m should be greater than g minus 1. So this is the investment equation. So what is k? Total number of variables 1, 2, 3, 4, 5 and 6. K is equal to 6. G, how many equations are there in the total? 1, 2, 3. G is equal to 3. And M is how many variables are there in the model of estimation? 1, 2, 3. So there is a correction over here. M is equal to 3. G is also equal to 3. M is equal to 3. So we have K minus M, that is 6 minus 3. 6 minus 3 is equal to 3, and it is the other side it is 3 minus G is equal to 3, 3 minus 1. So we have 3 is greater than 2. There is a small correction over here, it should be 3. So we have 3 is greater than 2. It means your formula K minus M is greater than G minus 1. So we can say that the investment function is also identified, and rather it is over identified. So both the equations we have seen, the rank or condition and the order condition, they were such that both the equation, the saving function and the investment function, they were over identified. Regarding this third, this is an identity, so we do not test for them that it is. Now the final table can be presented to you in this format, that is the consumption function, the order condition said it is over identified, and also it is this rank condition was also satisfied. So the final remark is that this consumption is over identified. Now investment, we have seen the order condition was over identified, the rank condition was also satisfied. So we can say that this system, this investment is also over identified. The third equation we ignore. So based on this information, we can say that our system of equation is over identified, and we can use, although still we cannot use your classical linear regression system, classical linear regression OLS, we cannot use it, but we can use other methods like inverted least squares method, indirect least squares method we can use over here. So in order to estimate the parameters of the equation. Hope this lecture is clear to you. With this we end today's lecture. Thank you.